Hello everyone. Welcome back to machine learning sessions. In this session, we will learn about learn one rule. So this falls under analytical learning. Actually, there are sequence of topics to understand FOIL and sequential algorithms. First, you should know the working of the learn one rule. So we will start with this. Then we will see the sequential learning algorithm and FOIL algorithm as well. Okay. So in the learn one rule, first we will talk about how to learn sets of first order rules. Okay, so these first order rules are also called as the Horn clauses. And then we will see general to specific beam search. Okay, already you might be having an idea of this in artificial intelligence. If not also, we will see here. Okay, then we will see the learn one rule algorithm followed by an example which uses this general to specific beam search. Okay, first let us see how to learn sets of first order rules. Okay, so learning these sets of first order rules containing variables we call as the first order Horn clause. What is a Horn clause? A Horn clause is with at most one positive variable. Suppose if you have an equation in the form of, one second, just let me select the pen. Okay, so in an equation, if you have P or negation Q. So here I have one negative literal. I have only one positive. At max, you should have only one positive literal. Suppose if you have one more also, that should be a negated one. So I should have at max only one positive literal. So that is called as the Horn clause. So now, because of these sets of first order Horn clauses can be interpreted as programs in the prologue. So learning these first order Horn clauses so is also called as inductive logic programming. Okay. So then let us see one example. Let us take some two rules to describe the target concept ancestor. So let us see how to form this sets of first order rules or sets of first order Horn clauses. Okay. So here we are taking two predicates, parent of x comma y. Okay, so this indicates y is a parent of x. Always the right hand side variable will talk something about the left hand side variable. In any predicate, this is the order that we follow. Okay, so here we are saying y is the mother of x. Let it be father or mother. Y is the parent of x. Similarly, here in the ancestor relation also, the same notation we follow. Y is the ancestor of x. Okay, so let it be somebody in the family, but he is the ancestor. Okay, so using these two predicates. Okay, so let us see how to form the target concept. If we first use only one predicate, then so we can form the set of if-then rules or the first order Horn clauses. Okay, so if parent of x comma y, then we can say ancestor of x comma y. Okay, so this is one rule. Let us see one more rule. Okay, so here we are using both the predicates and we are deriving the target concept ancestor. Okay, so if parent of xz and ancestor of zy. Okay, so in this, we remove the common literal. I hope you know this formula. Okay, so in MFCS also you might have studied. Okay, so z and z gets cancelled and we will be getting x comma y. So then ancestor of x comma y. Okay, so this is how we will be getting the first order Horn clauses. Let us see the applications of these. Okay, so these are some of the research works that are done by earlier scientists. So the first application is learning which chemical bonds fragment in a mass spectrometer. Then learning which chemical substructures produce mutagenic activity. And then learning to design finite element meshes to analyze stresses in physical structure. See, learning these machine learning algorithms is not only pertaining to CSE, it has a wide variety of, it can be applied in very wide variety of subjects. You can see it is applied in chemistry and it is applied in physics and even mechanical people will use it. It is universally, everybody can use this particular one. So only machine learning is becoming so popular. Okay. So now let us see general to specific beam search. So in order to implement the learn one rule, okay, so general to specific search has to be performed through the space of possible rules in search of a rule with high accuracy. Okay, so in the general to specific search, so in short, we can call this also as a beam search. There what we do, so we try to expand only those nodes which will give us the high profit, right? So which satisfy the heuristic with higher value. Okay, so that means it should give us a high accuracy, but it need not give us the complete coverage of the data. Okay, so here the learn one rule algorithm is a greedy depth first search with no backtracking. Okay, so we are greedy about some heuristic, and with that we follow the depth first search ordering. Okay, so the best descendant is the one whose covered examples have the lowest entropy. So here the heuristic that we are using is the entropy. So we already know how to calculate the entropy. We have seen that in while we have discussed about the decision trees. Okay, so here the problem is there is a danger that a suboptimal choice will be made at any step. So when we are using this beam search, to reduce that risk, what can we do is we can extend the algorithm to perform a beam search. Instead of only simply performing general to specific search, we will perform a beam search where the algorithm maintains a list of k-best candidates at each step. Instead of having only one, we can have k-best. Then on each search step, descendants are generated for each of these k-best candidates, and the resulting set is again reduced to the k most promising members. So the same thing will be done repeatedly or iteratively. So beam search keeps track of the most promising alternatives. Which is the most promising alternative? The one with the lowest entropy to the current top rated hypothesis, so that all of their successes can be considered at each search step. Okay. So in short, what we are saying here is, so we are following general to specific search. Okay. So we will start with a generalized solution, and from there stepwise we will try to come to a most specific hypothesis. Okay. General to specific hypothesis we want to move. And for that we are following a greedy depth first search. And while following like that, we are taking help of beam search. And that too, we won't select only one best alternative. We will select k best alternatives or k best hypothesis. And we try to expand all of those. And finally, we reach to the specific hypothesis. And the measure that we are, the heuristic that we are using here is the entropy. So this is the algorithm that you should write in exams for the learn one rule. Okay. So here what we start with, the algorithm accepts three attributes. One is the target attribute, then attributes, examples, and the k value. So because we are selecting k best hypothesis. So how many best hypotheses you should choose? So that will be given here. And you know what is the target attribute, right? So always the last column which classifies the examples, either yes or no. I will show you in the example. Then first what we should do, we should initialize the best hypothesis to the most general hypothesis. And then we will initialize the candidate hypothesis. The same best hypothesis is chosen as the candidate hypothesis. And then 3 steps has to be performed. The first thing is generate the next more specific candidate hypothesis. And then we will update the best hypothesis, and then we will based on this best hypothesis, you have to update the candidate hypothesis, and finally you will return one rule, which is the best hypothesis. And here you can see the performance metric also. So here to calculate the performance, we are taking H examples. So these are the subset of examples that are matching our hypothesis. And then finally we have to return entropy, where entropy is with respect to the target attribute. Okay, let us see with the help of an example. Okay, so this example already we are aware of. So in the decision tree learning, we have seen. If you have not watched that video, I'll provide you the link here. You can watch that and you get an idea of what is happening here. Okay, I'll try to cover here as much as possible for those who are viewing it for the first time. Okay, this is the data set that we have considered. Based on this, so what is the more general hypothesis that should be chosen first, right? First, let us see the algorithm. So in the algorithm, we have to initialize best hypothesis to the most general hypothesis. What is the most general hypothesis? All question marks, right? As per our idea from the candidate learning or the finest algorithm, always the best hypothesis is one with all the question marks. So here we are choosing an empty one. Okay. So we are not having any constraints. Anything is acceptable. And the target concept is play tennis is equals to yes. Okay. So now what should be done? So this will be taken. This is our best hypothesis. Okay. So this best hypothesis only should be chosen as the candidate hypothesis. Yes, done. So then what we should do for all constraints, what we have to do, the set, we have to form a new candidate hypothesis. How we should form this new candidate hypothesis for each X in the candidate hypothesis and for each constraint in all the constraints, create a specialization of H by adding the constraint C. And we have to remove from the new candidate hypothesis if there are any hypotheses that are duplicates or inconsistent or not maximally specific. So such ones we have to eliminate. So first what we have to do, we have to take the set of all constraints, okay, which are in the form of A is equals to V, where A is the attribute and V is the value. Okay. So from this example, what are the attributes? So the attributes are outlook, temperature, humidity, wind and wind. This play tennis is our target attribute. And now for this outlook, what are the possible values? Possible values are sunny, overcast, and rain. In this column, if you see the various values, those are sunny, overcast, and rain. And under temperature, hot, mild, and cool. These are the options. Under humidity, high and normal. Under wind, the possible values are weak and strong. Okay. So for all these values, we have to form specific hypothesis. Okay. So let us take one by one value. At a time, only one constraint we will consider. So here the first constraint that we are adding is wind is equals to weak and wind equals to strong. For wind, two possibilities are there, right? First, I am selecting this wind attribute. Okay. So in this, the two alternatives are weak and strong. Under weak, the possible, most of the target attributes are yes. Okay. So only here, play tennis, we are giving yes. And then under strong, okay. So under strong, we have no here and no here. So I am selecting play tennis is equals to no. Okay. So let us see whether this is correct or not, whether this is consistent or not. Okay. Actually, here we have a set of yes and set of no's also. Okay. But if it is inconsistent, I should remove. So for that possibility also, here we are adding no also as an option. Okay. Next, we are taking one more. Humidity is equals to normal. Then we are taking play tennis is yes. This is the hypothesis that we are generating. Okay. So this is as per our choice. And then if humidity is equals to high, then we are taking play tennis, the target as no. So now what we should do is, so like this for each and every constraint, you can expand this tree further. So you can see the dots over here. Only 4 alternatives were taken here, or 4 hypotheses were only considered for these attribute values, and the remaining were not expanded. And now what we should do out of this, we have to follow a beam search, right? The best alternative we have to choose based on the heuristic. What is the heuristic that we are selecting? Entropy. Okay. So we know the formula for entropy. It is minus sigma I is equals to 1 to C Pi log base to Pi. And here we are taking minus of entropy of S. So only here that minus is eliminated. So now for all these 4, let us calculate the entropy. Okay. So under weak, if you see in this particular table, okay. So under weak, we have 6 positive attributes. That means target concept with S. Okay. 6 positive and 2 negative values. Under strong, we have 6 positive and 2 negative values. So then the entropy will be, only for one I have calculated this entropy because this will be a redundant lecture. Already we have taken enough time in the decision tree learning. If anybody have not watched, I will give the link here. You can please watch that. Okay. So PI, positive ones. So how many positive samples? We have 6 by the total number of samples, 6 by 8, log base 2. Okay, I forgot to mention base 2 here. Log base 2, 6 by 8 plus 2 by 8. These are the negative samples. Okay. So positive, negative, both we should consider. So only this I is ranging from 1 to 6. Log base 2, 2 by 8. So now if you simplify this, you are getting a value of minus 0.811. Then similarly for the entropy of wind, strong. For the weak, we have calculated. For strong, if you calculate, the entropy that we are getting is minus 1.00. I don't think so. It is 6 and 2. I think I have not modified this value. Let us see how much we have. How many attributes of strong with S? Here I have 1S, 2, 3. Okay, so only 3 positive samples. And then let us see the negative samples. Strong with no, 1, 2, and 3. Excuse me if I miss anything. So 3 negative samples. So then the entropy that you are getting is minus 1.00. The same formula we use and we will substitute. Actually, whenever we have equal number of positive and negatives, the entropy will become 1. Okay, so for this you need not calculate. The entropy is 1 when you have equal number of positive and negative samples. And then similarly, for the humidity, if you see, under humidity column, you have 2 options, normal and high. Okay, under normal, you have 6 positive and 1 negative samples. Under high, you have 3 positive and 4 negative samples. Again, if you calculate the entropy, okay, entropy of normal case, humidity with respect to normal is minus 0.592. And entropy of humidity with respect to strong is minus 0.98. Out of this, the minimum value that we need to select. Okay, so this is the value. So let us take this. So only this is the most promising one. So this branch was expanded further. Okay. So next, the next attribute we need to add. So now humidity was selected as the first option. Humidity is equals to normal. So you can see humidity is normal in everything. And then the next one we are adding, the next attribute value we are going to add on here. Okay. So that is wind is equals to weak and wind equals to strong. And then we are adding one more attribute value, that is outlook is equals to sunny, outlook is rain. Okay, outlook is equals to overcast is not expanded in this. Okay, so then here we are taking plate tennis is equals to S. Here we are taking plate tennis is equals to S. Okay, so in every alternative we are taking it. Again, here also we will calculate entropy like this and we will decide which one to expand further. Okay, so this is how we will be performing the beam search or the general to specific search. And finally, we will be coming to the more specific alternative. So like this, we have to done for all these attribute values. So here we have added one, right? Humidity is equals to normal. So like that for wind also, we should add one value. For temperature also, we should add one value. And for the outlook also, we have to add one more value. Okay, so then the conjunction of all this will give you the most specific hypothesis. There we stop the process. And one rule is learn. So the most specific hypothesis is the rule that is learned by our learn one rule algorithm. Let me go back to the algorithm once and I'll clarify you. Okay. So here the new candidate hypothesis that was The new candidate hypothesis that was selected initially was humidity is equals to normal, right? So when you expand some other branches, you might get some redundant ones also that you should eliminate. Okay, humidity is equals to normal. So this is the new candidate hypothesis that we have obtained. And this one will be chosen as the best hypothesis. And again, for all H in the new candidate hypothesis, okay. So again, we calculate the performance. That is, so first we have elaborated the tree, and then we have calculated the performance, and then we have updated the candidate hypothesis. Okay, so far our candidate hypothesis is not empty. Only one attribute value we have selected. So the same process has to be repeated until the set candidate hypothesis is not empty. Okay, iteratively you have to repeat the procedure, and finally when all are done, you will stop and you will return a rule of the form if best hypothesis, then prediction. Okay. So if humidity is equals, if you see the first step, there what was concluded? If humidity is equals to normal, then plate NS is equals to yes, like that. So if humidity is normal, and then we will add the next attribute related to wind. Okay. So let us take it wind is equals to V. I didn't calculate it, randomly I'm saying. And then related to temperature also, one more value we need to calculate, and related to the temperature, related to temperature and outlook also we have to calculate. Then latency is equals to this. So like this, one rule will be learned by our algorithm. So this should be the output of learn one rule. Okay. So hope you have enjoyed the concept. If you have any queries, do post in the comment section. And if you want any other topics also, let me know in the chat box. If you like the content, do like, share and subscribe. Thanks for watching. See you in the next topic.